This video demonstrates my project about multi-objective and regularization. This project is focused on the problem of choosing a vector that achieves a compromise in making multi-objective small. The idea is widely used in data fitting. The key tool in this project is range function in multivariate stars package. Multi-objective least square is to seek a vector x hat that minimize the multi-objective J1 up to Jk. The standard method is to choose x to minimize a weighted sum objective, shown in this formula, where lambda I are positive weights. We start with a special case of two objectives. The weighted sum objective is J equals to J1 plus lambda multiplied J2. We use some Julia code to demonstrate the result. In this plot, we can see that parameter lambda gives relative weight between J1 and J2. When lambda increase, J1 increase and J2 decrease. In other words, we put more emphasis on making J2 smaller at the expense of J1 bigger. And then we plot optimal trade-off curve. If we choose vector x corresponding in this point, we can always get a better solution in this area. So the best solution is located on the optimal trade-off curve, because there is no point z that is as good as solution on this curve. In this plot, we can also see that when lambda is small, J1 is small, and when lambda increase, J1 increase and J2 decrease. Then we set f equals to I, j equals to 0, and we get J1 and J2. In this case, J is shown in this formula, and hence we can get the solution x hat. In this formula, when lambda equals to 0, then we get the least square solution. And when lambda towards infinite, the coefficient x shrink towards 0. This is also called ridge regression. The penalty term lambda regularizes the coefficient x by shrinking them to reduce model complexity. Then we take an example. First, we generate a complex model with 31 parameters, and apparently this model is overfit. And then we use ridge regression to regularize the complex model. We set lambda equal to 10,000. And in this plot, we can see that the overfit is reduced. And the plot also shows the result. We can see that when lambda increase, the coefficient shrink towards 0. So how do we choose the regularization parameter lambda? In this project, we use k-fold cross-validation, and we use multivariate stars package. In this code, we first read data frame, and then we determine variable associated with the cross-validation. We set the range of lambda and define function for determining index of these sets. And we set a function to extract fixture x and label y. And we carry out ridge regression for each lambda, and then evaluate the error for each k cross-validation. And then we find the best lambda, and we carry out the ridge regression one last time. The result is shown in this plot. We can see that the best solution is around 7,600. But one limit of ridge regression is it does not reduce the number of coefficients. So we introduce lasso regression. The object is shown in this formula, and we use lasso package. From the results, we can see that when lambda increase, the number of variables decrease. So lasso regression can lead to zero coefficient to help us select important feature. So that's all. Thank you.